Well, hi there, boys and girls. I'm just letting you know when a change in our schedule, and I'm going to flip-flop, a little flippy-floppy. We're going to flip-flop Monday and Tuesday. We're going to do FTC Continued today, and then Tuesday we'll start FTC number 2 and average value. So I just want to let you know that. So you're going to title your notes today, FTC Continued. All right, so what I want to do is show you all the ways that this relationship between the antiderivative and the area under the curve of a function can be asked. So we know right now the integral from a to b of any function is equal to its antiderivative at b minus its antiderivative at a. And that's what you guys practiced in class. So I'm going to show you some different ways that this can be asked because there's a lot going on here. Here I've got a geometric picture of f of x and I'm asked for an integral and I don't have a function to find the antiderivative of. So I can't actually go find capital F and do capital F of b minus capital F of a. So what I have to do is interpret this simply as area under the curve. And it's got to be net signed area. That means that anything below the x-axis has to be a negative area. So let's take a look at this. I have a triangle. This triangle has a base of 1 and a height of 1, and so its area is 1/2. Then I've got, I can break this up any way I want, then I've got a rectangle, a 1 by 1 rectangle. That area is 1. Then I've got another triangle that has an area of 1/2. Now down here, this is tricky. This is a big triangle that has a base of 2, a height of 1. Base times height is 2 divided by 2 is 1. However, I'm going to have to count this as a negative 1. All of this is a negative 1 because it's below the x-axis. So when we add this up, we do 1/2 plus 1 plus 1/2 and then plus negative 1. That means that this answer should be A. All right, another one is simply where the integral is the question. This is what you guys did yesterday. You just answer the integral. I have the integral from 0 to x of cosine. It is possible for me to find an antiderivative for cosine. The antiderivative, of course, is sine. And then we just plug in the top, and then we plug in the bottom and subtract those because we're finding the change in the antiderivative. Now the sine of 0 is 0, so this is just sine of x, and so this answer is C. Now here's one way where it can be asked differently. Find one of the limits if you know the answer to the integral. So let's see how this would work. We want to find out what value of k makes this true. So what we can do is we can answer this integral in terms of the limits. What I mean is we go find an antiderivative for x and we evaluate it from 4 to k. We know to plug the k in and then plug the 4 in, and we set all of this equal to 10 because that's what it's supposed to equal. So 1/2 k squared minus 8 is equal to 10. So 1/2 k squared equals 18. So k squared equals 36. So k can equal plus or minus 6. And so that answer for 3 is C. So there's one we had to go backwards and find the value of A or B. Here's another one where we're just accumulating areas under a curve, keeping in mind that anything below the x-axis is negative. So we're going to fill this table in. We want to find capital F of 0. Well, capital F of 0 means plug 0 in for x. That would be the integral from 0 to 0 of f of t dt, where f of t is here. So what is the area under a curve from A to A, or from 0 to 0, or if these numbers match? Well, that means it has no width, therefore the area is 0. Got a visitor here, so I'm going to pause this. Okay, let's do the next one. Now we have to find, we plug in 2 for x. So we're going to find f of 2 by plugging 2 in for x, the integral from 0 to 2 of f of t dt. Well, I have a picture of f of t, so this means the area under the curve from 0 to 2. And that is a triangle. It has a height of 1 and a base of 2. 2 times 1 is 2, divided by 2 is 1, so that's 1. Now the integral from 0 to 3 of f of t dt, we need to think about this as just an extension of the previous one. We've already answered the integral from 0 to 2, so we just need to find out how much more got added on from 2 to 3, and then we can add that to this integral, because this is all this area under the curve. So here I have a trapezoid that has a height of 3. Well, one of the bases is 3, the other base is 1, so 3 plus 1 divided by 2 is averaging the bases, and then we're going to multiply that times the height. And so that has an area of 2 inside here, but we have to add that to this integral because we want to find the total area under the curve. So we've added 2 more area onto this one, and so now it's 3. Now what about the integral from 0 to 5? We just want to find out how much more area got added. So this is a 2 by 3 rectangle, and so we're adding 6 to the previous area, so now the area is up to 9. Then we're adding, from 0 to 6, we're adding a triangle. This is 3 by 1. So 3 times 1 is 3, divided by 2, this is 1.5. So we add 1.5 on. Now going from 0 to 7, this is actually going to be taking away some area because this is underneath the x-axis. This is a 3 by 1, but we need to think about that as a negative 3 by 1. So this is a negative 1.5 area, so we go back down to 9. Alright, so let's do some hard stuff. I've got this function here, m is less than n. I've got to find this integral from m to n of f double prime of x dx. Well, one thing I can do is I can go ahead and answer this with the fundamental theorem of calculus. This means go find an antiderivative for f double prime. Now, do you know what you take the derivative of to get f double prime? Or what an antiderivative of f double prime is? It is f prime. So I would want to take and evaluate f prime between m and n. So this would mean f prime at n minus f prime at m. This is the change in the antiderivative. The antiderivative of f double prime is f prime. Well, we don't have f prime. We can't plug in n and m, so we're going to have to find that. F prime of x would be 2ax plus b. So what is f prime at n? Well, f prime at n is 2an plus b. And then f prime at m is 2am. Wow, that's funny. 2am? Yeah, never mind. 2am plus b. And we want to subtract these values. So it is a Matchbox 20 song. Is it 3am? 3am, I must be lonely. Dun, dun, dun. That's right. Okay, so we're going to subtract these. So we're at 2an plus b, and I'm going to distribute that negative, minus 2am minus b. And so those b's cancel, and we get 2an minus 2am. And so we probably factor out a 2a, and we get times n minus m, and so that answer is b. So that was a little trickier. All right, let's take a look at another tricky one. We've got the value of 2 integrals, so this is like properties of integrals. We want to answer the integral from 0 to 7 of f of x. Well, what am I going to do here? Because here's a 0 and here's a 7, but I've got to do a combination of these two. So let's take a look at what happens if we turn this one around. We go the negative integral from 0 to negative 5. We have the right to do that. That's supposed to be 5 of f of x. So if we turn these limits around, then we know that this would be the integral from 0 to negative 5 of f of x would equal negative 3. Why did I turn that around? Because now I've got an integral from 0 to negative 5 and then negative 5 to 7. And this is an example, if you go back to your properties of integrals, where this intermediary value does not have to be between 0 and 7. But I now have the fact that the integral from 0 to negative 5 of f of x dx plus the integral from negative 5 to 7 of f of x dx. This should equal the integral from 0 to 7 of f of x dx, which is what I'm looking for. So I know that this integral right here is negative 3 because we negated that. We are given that this integral is 12. So we know that the answer to this is 9. That was tricky. Let's look at an even trickier one. answer B here. I'm going to give you a second to make sure you write this down because I'm going to erase all that stuff. It's going bye-bye like it never happened. Go to purple. All right, so here I've got to do the integral from -12 to -7, and I've got this f of x plus 7, and I don't even see the f of x plus 7 up here. There's not even a 12 up here. What am I going to do? Well, you can just start by remembering that the integral from a to b of f of x dx is capital F of x, whatever the antiderivative is, evaluated between a and b. That's a big, long evaluate. Back to the eraser. Skinny little eraser. Okay, I like that better. So what we're going to do is we're going to say that I don't know what the antiderivative is. Well, yes, I do. It's capital F of x plus 7. And we want to evaluate this between -12 and -7, which means we plug the top number in first. -7 plus 7 is 0. Plug in for x. That goes in for x. And then minus, then we plug in -12. If you plug in -12, you get -5. Wow, well, what am I supposed to do now? What is this value? What is capital F of 0 minus capital F of -5? Does anyone know? It's equal to this right here. This is the fundamental theorem of calculus. That has to equal the integral from -5 to 0 of little f of x dx. That means that this value is 3. That was tricky. All right. One last example. And here I've got an antiderivative, or sorry, capital F of x is an antiderivative of this. And so that means that this is little f of x. And I want to find f of 9 if f of 1 equals 0. And so how can we figure out something about the antiderivative from little f? Well, it's the area under the curve. The area under the curve of natural log of x cubed over x. Between what two points? Well, we know the value at 1. We're looking for the value at 9. So let's integrate from 1 to 9. If we integrate this from 1 to 9, this will be the antiderivative's value at 9 minus the antiderivative's value at 1. That's what this will equal. And since we've got a pretty little TI-89, we can turn on the charm. Oh yeah. I'm going to go ask my calculator for this value. Dear calculator, would you please integrate? Because I don't think anybody can find an antiderivative here, at least not yet. Would you please integrate the natural log of x to the third power divided by x between the points 1 and 9. And the calculator says argument must be a variable name. Okay, so what did I do wrong there? No. One thing I'm going to do is I'm going to go back here and clear my A to Z. I'm going to fix this while I'm pausing you guys. So, okay, well, I'm a ding-ding. I didn't do comma x, so that's what I did wrong. I forgot to do comma x, comma 1, comma 9. I'm going to hit diamond enter because I want a decimal. Calculator's busy. It's trying to find the area under this curve from 1 to 9. Might be just a second here. And it's 5.8269. 5.8269. That is the value of that integral. That is equal to f of 9, which happens to be what I'm looking for, minus f of 1. F of 1 is 0. So this means that this answer is, I guess we can add 0 to both sides, and we get that f of 9 equals that right there. Now we round the 3 decimal places always, so this answer is C. So on Monday we're going to take a look at a lot of different ways that FTC number 1 can be interpreted and how to use it, and I will see you guys then.